Okay, now we will go through the subtopic De Moivre theorem. Okay, by right, in order for us to find the roots of the z, our complex number, we actually can use De Moivre theorem, where it is actually derived from the polar form. We have z is equal to r cis theta, right? Okay, let's say if I want to find two roots, by right here, it's not two. If I want to find z to the power of z to the power of 2, z multiplied with z, so it is r cis theta multiplied with r cis theta. So when we expand this, you're gonna get r square cis theta here 2 theta. So usually when we have sine square x, it is actually not equal to sine 2x, right? Okay, the reason is because a sine is happening on the y-axis, but then if we have cis theta, okay, it is actually happening both on at sine and cos, okay, which is cos theta plus with I sine theta, which involve in x and y axis. Okay, when it involve in x and y axis, actually a full rotation happen. Okay, not like sine. When we do it, cannot do a full rotation because sine is only at y-axis, so different with cis lah. So that's why when we have theta here, basically it will do to us one full rotation. Let's say if I have square, by right they're gonna do 2 full rotation. If I have cube here, they will do 3 full rotation. So that's why when we combine them into cis form, you can multiply it with 2 theta, 3 theta, 4 theta based on the number of rotation. Okay, so from this you get z square is equal to r2 cis 2 theta. Now if you have z to the power of 3, also the same, r to the power of 3 cis 3 theta. So by right, from this we can assume that z to the power of n is r to the power of n cis and theta. Okay, so from here, in order for us to find or to form the De Moivre theorem, okay, you can use zk is equal to z to the power of 1 over n. Okay, this one, it depend on 1 over n is the nth root. It depend on the number of root that we want to find. Okay, so it is equal to r to the power of r cis theta to the power of 1 over n. So by right, when we expand this guy, you're gonna get r to the power of 1 over n cis theta plus with 2 pi k. Okay, 2 pi k divide with n. So why we do it like this? Because why we have 2 pi k plus with 2 pi k? Because it depends on how many rotation we do for that particular theta. Okay, it depends on how many times that we have to do full rotation. Okay, now from this you will get, this is your final form for De Moivre theorem. Okay, where your k will start with 0, 1, 2 until n minus 1. So let's say if you want to find they said find the square root. Okay, so by right, square root means you have to find 2 roots, which is you have to substitute. Your n right now is equal to 2. So by right, it is 1 over 2 lah. So your k will start with 0 and 1. So at the end of the day, you have to find z0 and z1. What is the complex number? Let's say you have to find cubic root. Okay, by right, your n is equal to 3. Okay, so it is 1 over 3. By right, your k is 0, 1, 2. So at the end of the day, you will get 3 complex numbers, z0, z1, z2. Okay, so that is how you do lah for this one. Now, to make, the next one. So we proceed to the tutorial question for De Moivre theorem, where they ask us to determine the square roots of the complex number z is equal to 4 cis 40 degree. Okay, so for this question, okay, they asked us to find the square roots. When they said find square roots, by right, we can, at the end of the answer, we will get 2 complex number, which is here your n is equal to 2. Okay, and then they provide also the z, which is equal to 4 cis 40 degree. Okay, now, so we have extra information for z is equal to 4 cis 40 degree. Okay. Okay, now from here you can get your r is equal to 4. Then you will get theta is equal to 40 degree. And then your k, you're gonna get start 0 and 1. Okay, because we have two roots, so start with 0 and 1 lah, until 1. And then the formula for the de Moivre theorem is z1 over n is equal to r1 to the power of 1 over n cis theta plus 2 pi k divide with n. So here you substitute n inside, so you're gonna get z1 over 2. By right, you will get here r to the power of 1 over 2 cis theta plus 2 pi k, we don't know yet, n is equal to 2. And then here you substitute the value of r and theta inside, you're gonna get r is equal to 4, 1 over 2 to the power of 1 over 2 cis theta is 40 plus with 2 pi k maintain divide with 2. Okay, 40 degree here. 4 1 over 2 is 4 to the power of 1 over 2 is actually square root 4. Okay, cis with 40 degree plus with 2 pi k over 2. You actually can separate them, 40 degree over 2 plus with 2 pi k divided by 2. Here you cross. Okay, now you will get square root 4 become 2, cis 40 over 2 become 20 degree. Pi k is actually 180 k, 180 degree k. Okay, so this is your form for zk. Okay, so from this we have to find z is equal to 0 and z is equal to 1. So now when z is equal to 0, k is equal to 0, you substitute k is equal to 0 inside zk that we got. Okay, so 2 cis 20 degree plus 100 degree multiply with 0. Here you will get 2 cis 20 degree. Okay, so cis you change to the form which is cos theta plus with I sin theta. So you will get cos 20 degree plus with I sin 20 degree. And then you just use calculator. Here you expand first, you're going to get 2 cos 20 degree plus with 2 sin 20 degree I. And then here you just use your calculator to get the value of 2 cos 20 degree, which is here you're going to get 1.8794 plus with, you use calculator also 2 sin 20 degree, you're going to get 0.684 I. Okay, so that is the final answer. The answer for Z0. So your Z0, the complex number is 1.8794. Then the next one we will do for Z1. Okay, Z1 is equal to 2 cis. Okay, here we have 20 degree plus with 180 degree multiply with k, which is our k right now is equal to 1. So you expand this, 20 plus 180, you're going to get 200 degree. Then here cis you change into cos 200 theta, 200 degree plus with I sin 200 degree. And then here you expand this guy to cos 200 plus with 2 sin 200 degree I. So you will get the final answer is negative 1.8794 minus with 0.684 I. So this is your Z1 and Z0 and Z1 that you have. Just this guy long. This one and this one. Because the question asks you to find the square root of the complex number. Yep. Oh yeah, one more thing. If they ask you inside the question, okay, show the square roots on Argand diagram. So by right, what you have to do is, here you have two coordinate bar, which is the first one is 1.8794 and 0.684, and another one you have negative 1.8794, another one is negative 0.684. So when you have these two, so you draw your Argand diagram. Okay, so this is your x, this is your y. So 1.8794 maybe around here, and 0.64 maybe around here. Okay, so you have 1 point here, so this is your complex number. Another one is we have negative 1.789, so maybe around here, and another one we have is 0.684, which is maybe around here. So by right, this is a point straight like this. So this is how you show the Argand, show or indicate the two roots on the Argand diagram. And if they ask you determine the angle separating the roots, so by right, total angle here is 360, right? Okay, so if you check, right, this one, it is at the same, almost similar, it is actually 180 degree. This one 180 degrees. So how to determine this? Total is 2 pi over 2 pi, right? The total full rotation for a circle is actually 300 degree, right? So when you have square roots, you just need to divide with 2. Okay, so that's why you get 180 lah. But then you have to draw this diagram and also show that this is 180 degree, like how I draw on the Argand diagram. Let's say if you have 3 roots, so 360 divide with 3, or you want to use in radian also can, pi over 2 pi, so you divide with 3, so you get the answer lah. Okay, but then you have to show where is the point located lah. Okay, alright, so we proceed to the next question. Okay, for the next question, we have determined the cube roots of the complex number z is equal to 5 cis 5 cis 5 over 4 pi. Okay, so from this, what you have to do is, okay, extract first all the information that they ask you. Okay, which is, we have here, they ask you to determine the cube root. To determine the cube root by right, we have 3 roots that we have to find right now, which is your n is equal to 3. And then this is our complex number. Okay, so from z here, okay, so we have z is equal to 5 cis 5 over 4 pi. And then since we know already that our n is equal to 3, our r is equal to 5, our theta is equal to 5 over 4 pi. Okay, and then the next step is we substitute into the De Moivre theorem, which is we have zk is equal to z 1 over n to the power of 1 over n, which is equal to r to the power of 1 over n cis theta plus 2 pi k divide with n. Now you substitute all the information that you have. R is equal to 5, 1 over 3 cis theta, you have 5 over 4 pi plus with 2 pi k over n, which is equal to 3. Now what you can do is you separate first the angle that is inside cis, so 5 to the power of 1 over 3 cis, you separate 5 over 4 pi divide with 3 plus with 2 pi k over 3. So here 5 to the power of 1 over 3 cis, okay, 5 over 4 pi divide with 3, you're gonna get 5 over 12 pi plus with 2 pi k over 3. And then here what you can do is you separate this, because apparently we want to find, okay, by right, this is our zk, so we want to find z0 based on the k that we have, which is 0, 1 and 2. So by right, you will find z0, z1 and z2. Okay, because we have to find cube root, okay, Okay, now for z0, you substitute k is equal to 0 into the formula. So 5 to the power of 1 over 3 says 5 pi over 12 plus with 2 pi multiply with 0 divide with 3. So here you will get 5 1 over 3 cis 5 pi over 12. Now you change cis to the cos form, you will get 5 1 over 3 cos and sine. So cos pi over 5 pi over 12 plus with I sine 5 pi over 12. Then here you expand them, you will get 5 1 over 3 cos 5 pi over 12 plus with 5 1 over 3 sine 5 pi over 12 I. And then here what you can do is just find the value of this guy, x and y component. So by right, you will get 0.441 plus with 1.652i. So this is your z node, z0. Now you can do for z0, I mark this first. So now you can do for z1, which is equal to 5 to the power of 1 over 3 cis 5 pi over 12 plus with 2 pi multiply with 1 divide with 3. Here you will get 5 to the power of 1 over 3. Okay, cis 13 pi over 12. Now you separate them in you transform into cos and sine form. Okay, which is you get cos 13 pi over 12 plus with I sine 13 pi over 12. And then you expand this, we'll get 5 to the power of 1 over 3 cos 13 pi over 12 plus with 5 1 over 3 sine 13 pi over 12. So you will get is equal to negative 1.6517 minus with 0.4425i. Okay, so my calculation might be different with the decimal place lah, so you better check properly. Okay, and then here is your z1 bar. Okay, so it's better for you to take at least 3 decimal place lah. Okay, so now we will find the third root, which is z2. So we have 5 to the power of 1 over 3 cis 5 over 12 pi plus with 2 pi multiply with 2 divide with 3. So you will end up getting cis 7 over 4 pi. So from here, convert into the cos and sine form. So cos 7 over 4 pi plus with I sine 7 over 4 pi. And then here you expand them, 5 to the power of 1 over 3 cos 7 over 4 pi plus with 5 to the power of 1 over 3 sine 7 over 4 pi I. Then you solve this, you can get equal to 1.2091 minus with 1.2091 I. So this is your z2. So by right, you have your 3 value right now lah. Okay, like this. So from here, if they ask you indicate the 3 roots on the Argand diagram or show or illustrate all the root on Argand diagram, you have to draw Argand diagram like this. Okay, and then here you list down all the coordinate that you have: 0.441, 1.652. Here you get negative 1.6517, negative 0.4425. Another one you have 1.2091, negative 1.2091. So you find all of this point, which is 0.44. Let's say here is, this is 1, this is 2, negative 1, negative 2. Okay, this is 1. This is negative 1. Okay, let's say the first one we want 0.441, 1.6, maybe around here. Okay, another one you want negative 1.6517, negative 0.4425, maybe around here. Maybe I just put you just catch only this part. Okay, oh sorry. Sorry, I think this one a bit disturbing Okay, another one is 1.2091, 1.2091, so maybe around here. Okay, so by right, this is the we already illustrate all the roots on the Aragon diagram, and then sometimes the question will ask you to determine the angle that separate the roots. So you have to find out what is the angle here, these three. Okay, so basically here you can just use total rotation for the circle is 360 degree, right? So since we have 3 roots right now, so you divide with 3, which is you're gonna get equal to 120 or 2 pi over 3. So this is 2 pi over 3, 2 pi over 3, 2 pi over 3. Okay, so that's it for this question and for this topic lah. Okay, thank you so much for listening.